Jump drives, a staple in science fiction literature and media, are innovative concepts that facilitate swift and often instantaneous travel between distant points in space. These fictional devices allow spacecraft to bypass the limitations of conventional propulsion systems, enabling them to cover immense cosmic distances in the blink of an eye. Jump drives serve as captivating plot devices, driving narratives forward by opening up new avenues for exploration, conflict, and discovery in the vast expanse of the universe. The fundamental idea behind jump drives involves manipulating space-time, or tapping into higher dimensional spaces to create a shortcut between two distant locations. While the specifics vary across different stories and franchises, the overarching principle remains consistent: bypass the linear limitations of space travel by taking advantage of some form of exotic physics. Whether through wormholes, subspace, hyperspace, or other imaginative constructs, jump drives offer a means to propel characters and ships into uncharted territories with dramatic and often breathtaking consequences. One of the most compelling aspects of jump drives is their capacity to redefine the scale of space travel. In contrast to the vast timeframes required for interstellar journeys using conventional propulsion methods, jump drives condense these timeframes into nearly instantaneous events, offering a transformative leap in the exploration of fictional universes. This acceleration of space travel not only catalyzes epic adventures, but also introduces unique challenges, such as navigating through dangerous regions, dealing with potential time dilation effects, or encountering unforeseen obstacles in the fabric of space-time. The portrayal of jump drives varies widely within science fiction. Some stories explore the scientific and technological intricacies of how these devices function, delving into speculative theories that often push the boundaries of our current understanding of physics. Others prioritize narrative and character development, using jump drives as catalysts for exploring themes of isolation, culture clash, or the juxtaposition of different civilizations and species. While jump drives remain firmly within the realm of science fiction, they continue to inspire scientists, writers, and thinkers to consider the possibilities and challenges of interstellar travel. While we have yet to uncover the means for instantaneously jumping across the cosmos, the concept of jump drives invites us to dream of a future where the stars are more accessible, where the vast distances between celestial bodies are navigated with the same ease as crossing a street, and where the mysteries of the universe become the backdrop for stories of exploration and human curiosity. Einstein-Rosen bridges, also known as wormholes, are intriguing hypothetical structures that emerge from the mathematics of general relativity, proposed by physicists Albert Einstein and Nathan Rosen in 1935. These structures are often depicted as shortcuts or tunnels connecting two separate points in space-time, potentially allowing for faster-than-light travel or instantaneously traversing vast cosmic distances. The concept of wormholes captivates the imagination, offering a doorway to distant corners of the universe and raising questions about the nature of space, time, and the fundamental laws of physics. The basic idea behind an Einstein-Rosen bridge involves the bending and warping of space-time to create a tunnel-like structure. Imagine space-time as a fabric, and a wormhole as a fold or wrinkle in that fabric that directly connects two distant regions. While the concept is mathematically elegant, the formation and stabilization of such structures would require exotic forms of matter with negative energy densities to keep the wormhole from collapsing upon itself. The nature and existence of such exotic matter remain speculative and have not been observed or produced in any controlled manner. One intriguing aspect of wormholes is their potential to provide shortcuts through the vast cosmic distances. However, traversing a wormhole is not as straightforward as stepping through a door. Theoretical challenges include the possibility of immense gravitational forces, time dilation effects, and the question of whether a wormhole could be controlled or manipulated to serve as a practical means of transportation. Moreover, the stability and traversability of wormholes depend on a delicate balance of gravitational and energetic conditions that are not yet fully understood. Wormholes have played a significant role in science fiction, often serving as plot devices for interstellar travel and time travel scenarios. Works like Interstellar and Contact have explored the implications of wormholes on space exploration and communication with extraterrestrial civilizations. While current scientific understanding suggests that traversable wormholes are unlikely to exist, they remain a captivating subject of study and speculation in theoretical physics, inspiring researchers to investigate the fundamental mysteries of the universe and push the boundaries of our knowledge of space-time. As our understanding of gravity, quantum mechanics, and cosmology continues to evolve, the potential existence and properties of Einstein-Rosen bridges remain an open question, inviting further exploration and investigation into the fabric of reality itself. Warp drives and hyperdrives are both fascinating concepts in the realm of science fiction, offering means of achieving faster-than-light travel and enabling interstellar journeys that would otherwise be impossible within the constraints of known physics. While they share the overarching goal of bypassing the limitations of conventional space travel, they are distinct in their theoretical principles and the conceptual frameworks they rely upon. Warp drives, popularized by the likes of Star Trek, operate on the concept of bending space-time itself. They propose the creation of a warp bubble, or Alcubierre drive, around a spacecraft, in which space-time is contracted in front of the bubble and expanded behind it. This essentially allows the ship to surf on a wave of compressed space, enabling it to cover vast distances without violating the laws of physics that prohibit objects from exceeding the speed of light. However, the theoretical feasibility of warp drives hinges on the existence of exotic matter with negative energy density, a concept that remains speculative and unproven. In contrast, hyperdrives, often seen in franchises like Star Wars, typically invoke the concept of entering a different dimension or a parallel space where the laws of our universe don't apply in the same way. Hyperdrives are often portrayed as tunnels or shortcuts through this alternate dimension, allowing ships to travel immense distances in a much shorter time from the perspective of those within the ship. Unlike warp drives, hyperdrives don't directly manipulate space-time, but instead take advantage of an extra-dimensional space to achieve faster travel. While both warp drives and hyperdrives are rooted in science fiction, they offer unique storytelling possibilities and cater to different narrative preferences. Warp drives, with their focus on bending space-time and relativistic effects, can lead to intriguing plot lines involving time dilation, alternate realities, and relativistic physics. On the other hand, hyperdrives, with their emphasis on accessing alternate dimensions, can spark narratives involving encounters with exotic beings or the exploration of mysterious realms that defy our understanding of the cosmos. From a technological standpoint, both concepts present enormous challenges. The theoretical underpinnings of warp drives involve complex calculations and require the existence of speculative forms of matter. Hyperdrives, while sidestepping some issues of relativistic physics, introduce their own set of challenges related to the nature of the extra-dimensional space they tap into, and how such access could be controlled and harnessed. In the realm of speculative fiction, both warp drives and hyperdrives offer captivating ways to imagine humanity's exploration of the cosmos beyond the confines of our current understanding of physics. Whether through bending space-time or traversing alternate dimensions, these concepts continue to inspire writers, scientists, and dreamers alike to envision a future where the stars are not out of reach,